On the one hand, it concerns the big search for a unified physical theory, and on the other hand, the chances of new technologies which are connected with an extended field theory. As a necessary consequence of the derivation which roots strictly in textbook physics and manages without postulate, scalar waves occur which could be used manifold. In information technology, they are suited as a carrier wave which can be modulated more dimensionally, and in power engineering the spectrum stretches from the wireless transmission up to the collection of energy out of the field. Neutrinos, for instance, are such field configurations which move through space as a scalar wave. They were introduced by Pauli as massless but energy-carrying particles to be able to fulfill the balance sheet of energy for the beta decay. That means they have energy. They are energy-carrying. Nothing would be more obvious than to technically use the neutrino radiation as an energy source. My special subjects are vortices, and here we find the first example that vortex and anti-vortex are forming a physical basic principle. What everyone of you knows is perhaps the tornado, and in the eye of the tornado the same calm prevails as at great distance, because here a vortex and its anti-vortex work against each other. In the inside, the expanding vortex is located, and on the outside, the contracting anti-vortex. One vortex is the condition for the existence of the other one, and vice versa. Already, Leonardo da Vinci knew both vortices and has described the dual manifestations, as you can read in my books. I've explained there. I have the hint there, you see, for yes, the historical books and so on. In the case of flow vortices, the viscosity determines the diameter of the vortex tube where the coming off will occur. If, for instance, a tornado soaks itself with water above the open ocean, then the contracting potential vortex is predominant and the energy density increases treatingly. If it, however, runs over land and rains out, it again becomes bigger and less dangerous. The conditions for the bath tube vortex are similar. Here, the expanding vortex consists of air, the contracting vortex consists of water. In flow dynamics, the relations are understood. They mostly can be seen well and observed without further aids. In electrical engineering, that's now my stuff, because I'm an electrical engineer, it's different. Here, field vortices remain invisible and not understood. Only so the Maxwell theory could find acceptance, although it only describes mathematically the expanding eddy current and ignores its anti-vortex. I call the contracting anti-vortex potential vortex and point to the circumstance that every eddy current entails the anti-vortex as a physical necessity. Because the size of the forming structures is determined by the electric conductivity in conducting materials, the vortex rings, being composed of both vortices, are huge, whereas they can contract down to atomic dimensions in non-conductors. Only in semiconducting and resistive materials the structures occasionally can be observed directly, perhaps in high tension capacitors. You can see spots, round spots. That means you can see the effect of this vortex principle. The approximation, which is hidden in the Maxwell equations, thus consists of neglecting the anti-vortex dual to the eddy current. It is possible that this approximation is allowed as long as it only concerns processes inside conducting materials. If we, however, get to insulating materials, the Maxwell approximation will lead to considerable errors and it won't be able to keep it anymore. I will give you an example. Here, the high tension cable. As an example, we get problems of the continuity in the case of the coming off of vortices. And no, this was the wrong one. How to? Yes. In conductive materials, vortex fields occur. In the insulator, however, the fields are irrotational. This is what textbook physics are telling us. And I do not agree with this. And I say that's not possible, since at the transition from the conductor to the insulator, the law of refraction are valid, and these require continuity. Everyone who has glasses on his nose knows that these laws of refraction are valid, and they are working, especially on the transition from conductor to non-conductor. That means if you have vortices in one part, then you must have them as well in the other part, and this makes problems if one field is a vortex field and the other one not. So you can say hence a failure of the Maxwell theory will occur in the dielectric. We always have the same problems if we have this situation, perhaps in a high tension cable between in the transition from conductivity to non-conductivity.